Welcome to the Dr. Data Show. I'm Eric Siegel.
And I'm Luba.
Woohoo! Wow, just like we rehearsed it. Luba, I have a question. What do you like better, predictive AI or generative AI?
Both swirled together in a cone.
You like that? So is that your way of saying you don't want to play favorites, or you? I mean, it's fine to say that they help each other, but I kind of feel like you're evading the question. You
want me to pick
which is your favorite child?
That's such a mean way of putting it.
No, that's a silly joke. But seriously, I mean, they can help one another, but any given project is inherently or fundamentally either kind of for the most part, either a predictive AI project, which maybe uses generative to help it, or a generative AI project that might use predictive as a component or to help it in a certain way.
Right. So for different tasks, a different one is suited.
So you don't have like a subjective feeling like this one's better or more cool or awesome or exciting or interesting. Nothing subjective.
I'm very excited about generative AI.
Okay.
But I have, a lot of experience in predictive and love to see that as well.
Right. So, yeah, I mean, I've been writing, that's what we're going to cover today. We're going to make clear the difference and why they're destined to remain distinct. And then try to do a comparison and say, why do we even have to compare? They solve different problems, but in fact, there is sort of a reason to put them head to head. But I'm kind of like you, like subjectively, yeah, large language models are the most amazing technology I've ever seen, something I never thought I'd see in my lifetime. It's mind-blowing. I get my mind blown almost every time I use them. But other than just sort of the sci-fi unprecedented awesomeness, there's also the question of value, of utility, of the degree to which it's helping you or helping an organization do things in a way that's like more cost effective, more profitable, better for the world. There's a lot of different metrics, and it's not clear that one's better than the other.
Which one's making the world a better place? Quick, go.
Well, predictive AI has definitely been successfully deployed more, but of course it's got decades of head start on generative. But I sort of have that feeling of like, okay, in a nerdy, subjective way, like if I didn't have a day job, I might sit around playing with language models. Going back in the 90s, I was in the natural language processing research group for 6 years during my PhD at Columbia, and
So it was your first
it's like
love,
it's all
your
edge
first AI
case.
love.
What'd you say?
Your first AI love then.
Was natural language?
Natural language.
No,
in general.
No, I always kind of liked linguistics and the idea of computationalizing it, figuring out the algorithm. But no, my love has always been machine learning more than that. But I thought it was kind of cool. But you just can't get computers to do it. Everything's an edge case. It's all too brittle. It doesn't work. So the fact that predicting the next word, and to put it in overly simplistic terms, actually scales this well now and has as a side effect the ability for the machine to do all these tasks and be so seemingly human-like and have a lot of utility. I mean, right. So that's the stuff that is jaw-dropping. But so to delve in, let's just make sure we define our terms. How about I'll define predictive and you define generative? Is that all right?
Sure. Why are we, what are we doing?
Well, for listeners who may not be entirely clear of what the difference is and why they are indeed. So they both use machine learning. They're both built with machine learning, right? Which is learning from data to predict. But they are very different endeavors. They're very different types of projects. They're very different categories of use cases of machine learning, Predictive analytics learns from data to predict on the level of organizational unit. So who's going to click, buy, lie, or die, commit an act of fraud, which transactions turn out to be fraudulent, which credit application is going to default if you grant them a loan. So any kind of outcome or behavior on that level of detail, which is very detailed, right? It's not a forecast how many people are going to buy ice cream cones next quarter. It's much more granular. It's which individual is this individual likely to buy an ice cream cone, and how about this one, and how about the other million one at a time? So it's on that level of granularity, maybe less granular in a sense than generative AI that's using the model and applying it for every pixel of every frame of every video or every next token, which is mostly a word while it's generating a huge amount of text, right? So maybe less, but relatively speaking, pretty granular, but still on that sort of organizational level where the thing that you predict, is this customer going to cancel? Is this transaction likely to be fraudulent? Directly informs the action with that organizational element or transaction, right? Human, consumer, healthcare patient, B2B enterprise customer, transaction vehicle that might break down, factory component or machine that might break down, whatever that individual unit is, then you've got a prediction on the outcome or behavior that matters in order to decide whether to investigate, incarcerate, set up on a date, or medicate, whether to inspect this machine and do proactive maintenance, which is costly, not the least of which because you might have to actually shut down that part of the factory momentarily, but typically less expensive to correctly, proactively do maintenance in comparison to having an unhappy surprise of a machine breaking down.
You sound like our Kauai yoga instructor. Do you remember that guy? He was like an auction person in a yoga class. Do you remember?
Vaguely. I mean, I know that. So I haven't done hot or Bikram yoga nearly as much as you, but over the decades, some good number of times, and I do remember a couple times having like the auctioneer type.
Yeah.
Well, this is my
tiny room.
This is my desperate attempt to keep people's attention, right?
That's what he was trying to do too.
Okay, well, so that's the difference. So, I mean, and we can delve into a little bit more concrete, but most people are already familiar with generative AI and large language models, multimodal large language models that generate media and writing and images and then can be used for conversational AI. And we can go through some more of those depending on how this conversation goes. But the fact is, in a nutshell, here's why they really are different things. And generative AI doesn't take over predictive AI. That is to say that a project that's predictive AI in nature is inherently a predictive AI project, even if it were to use generative AI as a component to help it. And the reason is, in a nutshell, is because uncertainty is not going anywhere. The ability for the machine to do some level or some degree, and that's a very hard thing to quantify, but some degree of human reasoning, which generative AI does, that ability does not remove the fact that we will still always deal with uncertainty on a per case basis, and that we will not have a magic crystal ball. And so the best we can do is put odds on these outcomes. We can't predict with really high confidence for either positive or negative outcomes who's going to click, buy, lie, or die. So we have the next best thing to a magic crystal ball, which, to remove all doubt, we do not have. But the next best thing we have is called probability. And probability sounds boring, but it's just a number between 0 and 1 or 0 and 100 that puts the relative odds on that particular thing or outcome you're trying to predict for that particular case. And that's extremely valuable to triage, prioritize cases for who should be, contacted or inspected or whatever the decision that you're driving for that particular function is. So even if there's diminishing returns as the analytical methodology, as the core number crunching technology and algorithms improving or increasing complexity as they successfully do for large language models. But even the most complex model you could ever conceive of, there's always going to be some diminishing returns. And yes, you can get the predictive performance a little better, but we're still going to be far away from most of those types of predictive goals from a magic crystal ball. So that's why we're going to have projects that are still predictive AI, or previously called predictive analytics, still called predictive analytics as well, right? Or you could just call it enterprise machine learning, right? So that's why, that's the premise to this question about comparing the two. There's another question is, why do we have to compare them? Is it a competition? But first of all,
it's a competition of money.
They are two distinct things. So you get a lot of people out there who are kind of new to the analytics in the field or new to the AI, and they're kind of like, well, it's all prediction. You're predicting the next word. Everything's prediction. Yes, but just practically speaking, in terms of what the project is meant to do for the company or organization, they very much differ greatly. If you're dealing with odds and probabilities, it's a whole different kind of discipline and endeavor, one that's been fairly well honed over the last few decades, although, we have strong feelings that it's still also a relatively in an infantile state. It has some maturing to do as well.
It does. It's also way less sexy.
It's super less sexy.
Probability was my least favorite class in college, by the way.
I never took probability.
Oh my gosh, yeah.
I never properly learned a lot of probability and stats until I was teaching the grad level machine learning course at Columbia.
And
I was like, oh, I better learn this thing. Joint probability distributions and
put these balls in a hat and figure it out. That's all probability, different balls and different hats.
But I was motivated. I was like, oh, this is cool. This is a different method to learn from data, to create a different kind of, there's a lot of competing machine learning methods, predictive modeling methods like decision trees and ensembles and neural networks. And to learn to understand how they're designed,
that's a way better way. That's a way better way to
learn
it.
That's why it was interesting to me, because I was motivated.
Applied probability.
I mean,
please.
To set a little more context, at the time, I had fallen in love with the notion of machine learning and a couple particular machine learning methods in the very early 90s. And then it wasn't until several years later was on the faculty teaching that course that I was like, it's not just decision trees and genetic algorithms, which was my favorite at the time. I thought genetic algorithms were going to defeat neural networks, right? So it turned out neural networks definitely won. But at that, when I was then teaching a proper course about the topic, it was more about, let's go through all the different algorithms. Some are much simpler than others. Some are more opaque or transparent than others. There's pros and cons. As they get more complex, there's diminishing returns in how well they do, but sometimes it's worth it. All that kind of stuff. And lo and behold, fall of 1997, the first time I taught that course, the first sort of proper, nice textbook. And I know to many listeners, you think, textbook? That sounds so boring. But before the first textbook, all you got is a bunch of research papers. Those are a lot worse, right? And it's scattered. But this was the first textbook to pull and nicely summarize and put into a unified framework it wasn't perfect, but for most of the methods, like the ones I just listed, it did a great job of stepping through them, one chapter per method, and putting a framework on it. In fact, even before decision trees, it starts with an even simpler method that's simpler than, it's basically just one rule of a decision tree. I can't remember what they called it.
What was it called? Do you remember?
It doesn't matter. I mean, it's just more of a way to enter the idea of learning from data and just come up with a very simple pattern. It's like one rule of a decision tree, one path from the root to the leaf, and then expands the decision tree, does neural networks, does naive Bayes.
Yeah, because I remember elements of statistical learning, but that's definitely
that came later.
Way later.
No, this was so that textbook is called Machine Learning by Tom Mitchell of Carnegie Mellon, and he pretty soon after that, I think he was in the computer science department, and it was somewhere around then or pretty soon after that where they actually created the first separate machine learning department that I guess he was the chair of. So that textbook, the first edition of that textbook, came out just in time for me to be teaching that course for the first time, fall of 1997. And as fate would have it, as I reminisce, in August, right before the semester began, I was at a conference and he was there, and I got to corner him for lunch and ask him a whole bunch of teaching questions. So the stars aligned. That was great. So I got a little bit more of a balanced view of the machine learning field. What were we talking about here today?
We went down one rabbit hole after another.
I finished though. I got to the dead end. We're done.
Yeah.
Well, let's pop the stack. Right. So anyway,
predictive versus generative.
I would say that so far we've established that predictive AI is its own kind of project, different than generative AI. Is there anything else we want to tell the listeners about what generative AI? I mean, generative AI is very typically you're creating this one big multimodal large language model that is meant to be used for a whole bunch of different purposes.
A foundation model.
Right. So that's a really big difference. If you're doing a predict, and then yes, you as we've spoken in previous episodes, you're going to do things on top of that to refine it for a particular problem or project. But that's on a fundamental level, that's really a big difference, because with a predictive project, you're creating a new model from scratch, a much simpler model to predict, which customer is going to cancel or whatever you need to predict.
And then ultimately refining that model and iterating and improving. Whereas here you're just essentially building applications on top of existing models.
But because of that, it introduces a lot of confusion and complexity for newcomers as far as understanding the difference, because generative is such an ill-defined, or that is, say, potentially broad field. It's meant to be a very, very multi-purpose model that could be used for just ad hoc, informal Q&A kind of co-pilot, get information, deliberate on decisions, help you make life decisions or business decisions. And then on top of that, there's this whole message out there, and this is where you're really starting to get into the hype. It's not 100% vapid hype. Some of it's very much real, but very quickly it becomes hype, and that's where you're having the thing assume a human role. So customer service agent, analyst, virtual assistant, right? And it can do some of that. Life partner. And it's funny because it's true. It's true, yeah. But you're real, right? Just checking.
So you think.
I just wanted to make sure.
I am the humanoid robot inside your home.
Oh, nice. Do the dishes.
Aw.
Okay. What kind of a robot are you? You get annoyed with my requests? So a lot of people, it's really fun to get excited about generative AI, and it's kind of like eat your cornflakes to be like, here's predictive AI. But you and I tend to be kind of eat your cornflakes, because it's kind of like, look, the white hot spotlight on generative is so overwhelming. It's almost like the world, at least in the media and headlines, and very much not the case in terms of actual projects out there, but in terms of what you're seeing on the surface, it almost looks like generative AI is it. It's the end-all, be-all, and if people say the word AI, they mean generative AI specifically in most cases. It's so cool and exciting, but with that attitude, if things go too far in that direction, we're leaving a lot of value on the table, because predictive. So somebody's got to advocate for predictive AI, right? So my advocation is usually something like, hey, this predictive AI is the technology you turn to improve your existing large-scale operations. Business is a numbers game, and you tip the odds slightly in your favor by playing the numbers game scientifically based on what you've learned from data, and that has even just slightly tipping the odds by predicting better than guessing and acting on those predictions judiciously and systematically over many cases. You tend to have this vast improvement on the bottom line. So in that way, predictive AI projects aren't going anywhere, shouldn't go anywhere, and it's a loss if too much is taken away, if the wind is out of their sails, if too many resources, investments, attention, and data scientist time is taken away from those projects, because oftentimes that's by far the low-hanging fruit as far as getting concrete, provable, feasible, accessible value.
Yeah, it's a big distraction right now from things that are actually. I mean, I'm sure a lot of these generative AI applications are generating value, like some of the applications that you brought up in our conversations, like for sales teams, improving that pipeline and those conversations. But I agree with you that it's a little bit of a distraction from the old school predictive AI.
Super distraction.
Yeah.
I mean, my sense is from a lot of sort of backroom conversations, as well as sort of the distribution of speaking submissions for our conference, Machine Learning Week, May 5th through 6th in San Francisco, which is focused on both generative and predictive, and especially the hybridization, combining the two, is very much that predictive is alive and well. And you hear a lot of people say, hey, look, generative gets our foot in the door as a vendor, for example, or, at a Fortune 500, hey, everyone's expecting us to do some generative, but still the returns are coming from predictive. The opportunities abound in predictive. Predictive's older but old school. Most of its value is still largely untapped. It's happening, but I do feel it's a little bit at risk because there's this sort of messaging that generative AI is so overwhelmingly all-powerful. It's going to change everything, and it does everything, or it could do, or soon will be able to do. But by definition, it actually can't do predictive. It can help predict. It can help predict better. It may not be worth it because it's a much more complex model. Depends on the project. But even if it's helping, the project is still predictive. You're still dealing with odds, and you have to deal with this. It's not the rocket science part, but it's sort of a kind of nitty-gritty mechanical number crunching of like, okay, we've got all these odds. How do we decide where to draw the line as far as, which credit card transaction to block is potentially fraudulent? Those kinds of sort of strategic deployment or operationalization questions around a predictive project are pretty particular. So the nature of the project is it's a predictive AI project. It's still definitely, kind of its own thing. So when I go down this line of reasoning, as I did in a Big Think video, which has gotten a lot of views and also a lot of comments, and more than half the comments are positive. But a lot of the comments, when I make this kind of argument about, hey, don't forget about predictive, some substantial part of them are kind of negative. And I get the sense that some of them are kind of territorial. Hey, you're attacking generative AI. The intention here is not to attack generative AI, which is amazing, but potentially to criticize some of the over-promising hype, right? So that would be the place to criticize. But in any case, one of the things that I've seen about 15 times in those comments, I mean, there's thousands and thousands of comments, is people will accuse me. They'll be like, you're only making this argument because you're invested in predictive AI. Your startup does predictive AI. So that's why you're trying to take down generative AI, which is a false dichotomy, and it's not what I'm doing or why. But you're my co-founder of Gooder AI. And we're focused, we use GenAI, but we're focused on the sort of way you need to strategically run a predictive AI project so that it actually delivers value, right? So, even though it's the older technology, it still hasn't quite achieved a standardized, prevalent best practice in that regard, right? So we're trying to change that. So we're focused on predictive. Well, what do you think, though? I mean, are we, in what we're saying with this podcast, are we just defending our territory, or are we coming from a good place? Like, I
think we're definitely coming from a good place.
You do?
Yes. Yeah, I do. I mean, generative AI is certainly useful, and it's useful in doing predictive AI, but you still need to know the fundamentals in order to execute a predictive AI project. And generative AI is not going to do it for you from start to finish anytime soon, if ever. I believe even, ultimately down the line, however many years, there is a certain secret sauce that humans, for which humans will need to remain in the loop for even highly constrained predictive AI projects.
Yeah, I mean, you've just opened Pandora's box. That's like pretty much a religious debate, the degree to which that kind of, like if you gave generative AI access to machine learning modeling, SKI or library or whatever. I mean, we know that more and more parts of the machine learning or predictive AI project life cycle can be very much assisted by using a large language model. But sort of the religious debate is to, when can you just sort of give a big number crunching task that needs to deal also with very practical, pragmatic, business level realities to a machine, right? And I agree with you. I think that that's completely eliminating the human from the loop is when you're getting into that territory called AGI, and I think that artificial general intelligence, and I do think that that's overpromising. I don't think that we're headed. I don't think, as seemingly human-like and amazing and unprecedented as large language models are, I do. This sounds subversive, but I really don't think that actually represents a concrete step toward AGI. AGI, I think, is a much more audacious goal than many realize, and it's all too easy to be excited about the prospect of it, and excited and impressed by what we see in technology today, and seduced by its sort of seemingly human-like aura and all that, and sort of be like, oh, it's definitely headed towards being able to do everything a person can do. And I think that I think there's a big question: is when is it going to become pretty clear to the general public that promise was overzealous?
How far do we have to go down this rabbit hole before we crash down?
Right, and then we're gonna have to back out the rabbit hole.
Yeah. Drink
awkwardly,
drink the potion.
like for so
get big
long.
and get small.
So, by the way, to answer my own question, one perspective is I'm not arguing for predictive AI to also have its fair share because I'm invested in it. It's the other way around. I'm still invested in predictive AI.
They're completely separate. Yeah.
Yeah, because it's very valuable. So how would you characterize – well, that's the ultimate question, right? It's going to be how much should a company sort of invest in one versus the other. But before we answer that question, let's make it clear why that's a valuable question. Considering they're sort of apples and oranges, and they solve different problems. So in principle, they shouldn't compete. So what are we is it a red herring or somehow going to be some misleading ourselves even by trying to answer the comparison question? I mean, if we try to compare them, doesn't that mean we're buying into the idea that you have to choose between them, but you shouldn't have to choose between them because they solve different problems?
Well, yeah, we're not comparing them. We're talking about what kind of problems they solve and potentially how they can help each other.
Right.
But are you talking about in terms of the money question?
Yeah, I mean that's what it is, right? I mean, so a company is sort of like at some level and at certain points, companies are essentially going to be choosing. Because there's only so many initiatives or investments they can make,
right.
And they've got a limited data scientist team, and
they have to prioritize the initiatives themselves. Like, do we want to improve our sales pipeline, or do we want to improve our manufacturing out. I don't know.
Right.
They
So
have to
there's that.
evaluate
There's that
those.
question too. Like, what do we want to improve, and then which technology is right for it? But even, and that sort of seems like it's a problem that solves itself. But I don't think it necessarily works that way, because you've also just sort of got the infrastructure and the teams and the, that you're setting up in the enterprise in anticipation of all different units of the organization. Some are going to want a predictive, some are going to want a generative project. So you're not, even without enumerating the exact problems that you're going to try to solve, you're still making this executive strategic decision. And right now, the pressure, the heat, the excitement, the FOMO frenzy, it's all like you got to move it all to generative.
But everybody, I feel like almost everybody should be brought up to speed on generative. Even people that are working on predictive.
Should be, you mean they already are probably, or they
should be, because it's such a valuable tool.
Well,
how do you use it for?
Yeah, but you say, everyone should know about generative and how you use it. But I kind of feel like no one has to say what you just said, because there's already a frenzy. Whereas predictive, most people don't know the basic, accessible, interesting, fundamentals of it. And that's the thing that needs to be advocated for, and be like, hey, you should also learn this other thing. It's not arcane. It's still pretty cool what it means to learn from data to predict, et cetera.
Right, but not everybody on the team within the organization needs to know the intricate ins and outs of. I feel like there are a lot of people that don't know it that do need to know more. For example, the decision makers and the executives and people that are funneling the money. Yeah. And I think a lot of the content that you're putting out there speaks to that audience.
I mean, virtually everybody knows what ChatGPT and its competitors are.
Yes.
And has used one.
Yeah. So
in that respect, they know.
Mission accomplished.
Right.
Yeah.
Right. Whereas predictive, just the idea of like, what does it mean to, you have to decide what's predicted, what's done about it, and what's the metric of how well it's predicted, and just a few basic things. That is, it's sort of a book's worth, but a business level book's worth, right? It's not rocket science. A little bit of the under the hood is interesting to get a general idea. You don't need to know how internal combustion engine works in order to drive a car, but it's nice to know a little bit. But there is a bunch of expertise to know about. Even if you're not going to be ever driving a car, it's good to, if you're managing a bunch of people who drive cars, you should know what the steering wheel and the gas pedal do. So it's just sort of like some basic accessible info that generally people do not know about predictive AI projects.
Right. I agree with you.
So there's kind of a dearth there, which adds, generative AI is so much easier to use by definition. It's a language model, as in human language, natural languages, and therefore, I mean, arguably, maybe it's harder to use well instead of in terms of achieving established value. So here's the big question of the day. You're running a Fortune 500 company. What should be your division of investment between predictive and generative AI?
50-50 and see what happens.
Okay, thanks everybody for listening. Glad we got to that. Talking about queuing up a question. Well, as you know, the way I've been putting it is not too different from that. It's a little bit more malleable, but okay. I say most companies should probably invest at least as much in predictive, which is my way of saying, hey, let's try to get it up, keep it up at least around 50, around the same level. Try to keep it up about a 50-50 split. Even though I'm sure that lots of companies will, maybe they'll hear the message and they'll end up at 30-70, but that's a lot better than 5-95.
Well, here's the question: if that were to actually happen, would the whole generative AI industry come crashing down? Because they're spending more than they're actually charging for these subscriptions.
No, that's true. What are we talking about? Are we just talking about money, or are we just or should the metric be numbers of? Because I've never really thought this through. But maybe I would be happy for the world if I could sleep at night knowing that most of these companies, and of course it depends on the companies and the nature of the business, but that most of these large companies, are at least balancing relatively equally the number of projects, but also knowing that in order to do that, they still would not need to spend nearly as much on predictive. Predictive AI is much cheaper and much lower footprint, by the way. So if it were the same number of projects, maybe that's the way to think about it instead of the number of dollars. Is it much cheaper? Predictive AI?
Because it requires higher skilled, more expensive task force.
This is the problem with the KPIs on the strategic level, right? Like generative AI right now, generative AI, the foundation models, as it were, the large language models, some of them are free, right? But OpenAI and Anthropic and and Google, everyone who's making these foundation models are investing so much, and yet it's already kind of become a commodity. So they're relatively cheap to use.
They're cheap.
If you're using them at scale, though, they start racking up in comparison to using like logistic regression or even an ensemble model like XGBoost.
Yeah, but you're paying a data scientist living in San Francisco.
Right, so that
hundreds of thousands of dollars.
Yeah. But either way, you're probably paying a similar salary. So putting the HR costs aside, what I think that the tricky thing of trying to say, well, how much is the corporation putting into one versus the other, is that you're kind of getting most of the generative AI investments for free because you've got these billions of dollars investments making the foundation model, but they're not making that revenue.
No.
So
that's what's scary.
So at some point, it's a bubble, right?
It's a bubble, yeah.
I mean, it's weird. There's so many reasons to think it's a bubble. That's sort of the economic reason to think a bubble. The maybe more fundamental reason to think it's a bubble is that it's going to become, there's going to be a reckoning because it's going to become clear that it's overpromising. It's going to become clear that the notion of artificial general intelligence of a virtual human is a much more grandiose, overly ambitious prospect than has really sunk in universally. So the difference between what's feasible and what's been promised, right? That disillusionment, that's some point is going to be held to pay for that. So both things kind of spell major market correction or, things, but ultimately it's an economics question. And, economist is a statistician who tells you tomorrow why the predictions they made yesterday didn't come true, or whatever. That quote by Yogi Berra or whoever really made the quote. Everyone ascribes, when you don't know who made the quote, you always say it was Yogi Berra, who was a baseball player or umpire or something.
Okay.
I don't know. I just showed my ignorance about baseball. So that's so it's a little bit hard to say when we say, hey, they should be given equal weight or equal investments. We're not really defining our terms. There's a lot of wiggle room for what exactly we mean about that.
But the point is, it should be different than what it is right now, which is 99.9%.
Well, but hold on. I think evidence shows that these projects are still alive and well. They're just not so sexy or exciting, and
They're
so
not
they
being
don't get
publicized.
they don't get the light of day. But I think to this date, I think that it is pretty equal at large enterprise data science among the data scientist activity. In any case, that's my read. But certainly liable to change because the white hot spotlight and FOMO and elation, right? Elation is elation can be a problem, when you're overly excited about something and it's sort of too good to be true, right?
Yeah.
But until there's a reckoning, that momentum right now is still so strong, right? There's all kinds of kind of backlash and question, but it's such low volume murmurs, right? And part of that is because the press tends to focus. The press doesn't know how to talk about in general. they're non-technical journalists. They don't know how to really. I mean, there's plenty of exceptions, but for the most part, they don't know how to unpack the difference between overpromising hype and feasible tech, and because of that, so often the decision of what's exciting and newsworthy is around how many dollars.
Exactly.
So look, this AI celebrity is now worth $1 billion. They got this investment and this, so it just starts being about the money, and the investments in the foundation models are so disproportionate, and it's such a frenzy that right. So that sort of feeds into why, because if there's money, so somehow money equals credibility, right?
That's always been the case.
Right, for lack of what other metric. It's a very concrete, easy metric, right? So,
and now it's infected the.
I mean, let's talk abstractly, philosophically here. Like the phone, like the people with the deep pockets who can make these incredibly large investment decisions, right? These are going to tend to be people who've really prioritize money in their life, right? There are other priorities in life, or at least I read that somewhere in Wikipedia. And because they're kind of that ilk, they're also, and assuming most of them are not machine learning technical experts, they're also particularly susceptible to FOMO, fear of missing out, which means, hey, this is a way I might even be able to double my economic power, right? And the FOMO message with AI is so rich, right? It's such a seductive narrative. Yeah. They've been cultivating this narrative since the 50s when the inauspicious term AI was first coined, and then perhaps even more importantly through the 80s, 90s, and up till now with the science fiction movies, almost every single one of which includes essentially an AGI, right? And instead, you grew up watching anthropomorphic ducks and mice talk on your screen, and then you grow up and they're robots, but it's still that mechanism, that psychological mechanism, right? You believe, you see it, you see the future on your screen because you're suspending disbelief, because the actors are really good actors, and in that world, they're believing that this technological artifact is essentially human, right? Or a human level in general, right? So it becomes this very simple, or it feels like a simple, digestible conceit. And then therefore, sure, it'll, right? I mean, a lot of things came true, like the iPhone or all the smartphones are kind of very Star Trek relative to where we were before they existed, right? But just because you got the iPhone doesn't mean we're going to have transporters or faster than light speed or time travel, right? So it's a mistake. It's a mistake. There's a prevalent mistake.
Yeah. And where do we go from here?
I don't know.
Keep working on the good stuff.
So the people who advocate for for predictive, that is to say, hey, let's run business as a science. And that's what it is. It's the ultimate way
that's a good
to
way of putting
apply science in a systematic way over many cases where there's uncertainty, right? That's good, right? If it's for a good cause, great. If it's not, it also is just making things more efficient, which tends to help people, right? It helps productivity and livelihood across the population, right? And I don't mean to be a full-on capitalist and end all be all, but there is some value there. It's a neutral technology. It just makes things more efficient, like lots of technologies. So that tends to help the economy. So great. Let's not forget to do that, right? So the people who make that argument, like we are today, the predictive AI, don't forget about predictive AI. Don't forget, here we are. I mean, I might be 40, but I work out every day. I'm still pretty, value is attractive. That's my motto, right? Value matters. And sometimes it feels like the world forgets the concept of value, which is so ironic, right? But anyway, the people who are like us who would do that are going to always be the people less in power, right? Mm-hmm. If we were, if we owned a foundation model company, right, then the financial incentives to just talk the talk and walk the walk of LLMs would be overwhelming, mm-hmm. and we would probably end up doing that. And right, so and it kind of goes that point about sort of this important but less sexy thing remaining intact. Also reminds me of a quote I once heard, which is that people who push against AI hype sound smart, and people who produce AI hype get rich. Mm-hmm. So,
and on that note,
does that poignant comment? I don't know the degree to which it's true, but if that poignant comment doesn't help solidify our argument, then just ignore it. Pretend I didn't say that if you don't like it. It's sort of orthogonal to our argument, right? So anyway, I think we've done it. There's a lot of interesting stuff in predictive and a lot of really interesting ways in which generative AI helps predictive, right? Doesn't change the fact that the project is still going to be intrinsically a predictive one, dealing with odds. It's a very particular kind of discipline, but really fascinating to see the power of large language models help in both with the actual core prediction itself and also with just sort of the management and creation of the model, and the understanding of what the model does. That's what we do at Gooder AI. We put the mm-hmm. chatbot on top of its interface. You can see that at gooder.ai, right at the top of the screen on the right. And then conversely, right? I've been starting to say that and this is I think the title of my keynote coming at Machine Learning Week, that to help ensure a reliability layer for generative AI, predictive AI serves. And in fact, that's so important, and so important to realize the promises of Gen AI, that I believe that will be the next killer app for predictive AI, a reliability layer for generative mm-hmm. AI. So are we done? What do you think? Anything else?
Yeah, I think that's a good place to wrap it up.
Okay. We just hit 48 minutes. Great. Thanks, everyone, for listening. And we'll be back soon with another episode of the Dr. Data Show.
Woohoo.
Yeah.